Today we are doing Unit 5, Lesson 3, Dividing Complex Numbers. Before we can actually start dividing complex numbers, we need to learn about something called a complex conjugate. A complex conjugate is found by keeping the real number part and changing the sign of the imaginary on the original complex number. So let's go ahead and practice a few of these. So the real number part stays the same. Our imaginary changes, and so that becomes a positive 9i. So let's do another one. So our real number part will stay the same, so negative 8, and our imaginary part will change. So negative I. So there's our complex conjugate of negative I, 8 plus I. Now, what's a complex conjugate whenever it only has a real part or only has an imaginary part? Same rule is going to apply. So for our real, is going to stay the same. So the same rule is applying. So if we have a complex conjugate of 7i, that's only imaginary, and so it's going to change its sign. Now let's do a basic operation with complex conjugates. So if I want to find the sum of a number and its complex conjugate, so let's take negative 9 minus 2i. First thing I need to do is find its complex conjugate. So negative 9 plus 2i. And now I'm going to add those two things together. So adding together our real parts give us negative 18. When I take and add together our imaginary parts, they cancel out because a negative 2i plus positive 2i cancels. Let's do another one. Let's find the sum of 3 plus 7i and its complex conjugate. So step 1, find the complex conjugate. Now let's add them. So when we add them, our real number becomes 6, and our imaginary number cancels out. Every time you add a number to its complex conjugate, you're going to double the real and cancel out the imaginary. So now let's get into dividing. So when we're dividing complex numbers, you're going to again work with the conjugate. So you're going to find the conjugate of the denominator. So 7 minus 2i. And you're going to make that as you're multiplying it over itself. So we're multiplying by the conjugate over itself. And so to do that, we're going to have to use either FOIL or the box to multiply. Again, for visual purposes, I use the box. And so we have 1 minus 5i times 7 minus 2i. So we have 7 times a negative 2i, or minus a negative 2i. 7 times a negative 5i is a negative 35i. Negative 5i times a negative 2i is a positive 10i squared. I squared becomes a negative 1. So 10 times negative 1 is negative 10. We add together our real parts, and that gives us a negative 3. We add together our imaginary, and that gives us a negative 37i. And that becomes our numerator of the new fraction. To find our denominator, we're going to do the same thing, but we're going to be multiplying with the denominator fraction. So 7 minus 2i goes here. Gives us a 49 minus 14i. And 14i, when we multiply 7 times 2i, and 2i times 2i gives us a negative 4i squared. And so I squared becomes negative 1. Oops. And so that becomes a positive 4. So 49 plus 4 is 53. And then when we add together our imaginary, they cancel out. So 53 is my denominator. Now we need to split it apart into the a plus bi form. So we're going to take and split it up to where that 53 goes under both parts. And so we end up with negative 3 over 53 and negative 37 over 53. So before you start doing all that work, always look to see, is there anything that we can reduce, especially if you have just monomial over monomial. So let's look at it. The i's can cancel, and 6 and 27 can reduce by dividing both of them by 3, giving us a 2 and a 9. So 2/9 is 6i divided by 27i. And so now we end up with an I in the denominator. So we need to multiply by the conjugate, so negative 5i over negative 5i. And so when we multiply that, we end up with a negative 15i divided by negative 25i squared. I squared becomes negative 1. So 25 times negative 1 is a positive 25. Our numerator is negative 15i. And so when we look at reducing, those are both divisible by 5, giving us a negative 3i and a positive 5. When we write it, we always write the I after the fraction. We always write the negative sign before the fraction. So it's negative 3/5 I is all we're left with. Let's do one more similar to this. And so again, we're going to multiply by the conjugate of the denominator. So that's a positive 3i over 3i. 8 times 3 is 24i. The denominator is negative 9i squared. I squared is negative 1. And so we have 24i divided by 9. And so we're going to look and see what can reduce. 24 and 9 can simplify to give us 8 and 3. And the i's can go at the end. So 8 thirds I. So if you notice between these last two problems, if you have the I in the denominator, all it's going to do is change the sign of that fraction. And the I is going to come to the numerator. So now let's look at where we're taking and divided it by a complex number that has both a real and imaginary part. So the first step, again, is going to be finding that conjugate of the denominator. So 2 plus 6i. 2 plus 6i. And we're going to multiply these two fractions. So that numerator, we're just going to distribute. And so we end up with 14 plus 42i. To multiply the denominator, I'm going to go over here and use the box. 2 minus 6i and 2 plus 6i. 2 times 2 is 4. 2 times negative 6 is negative 12i. 2 times 6i is 12i. Negative 6i times positive 6i is a negative 36i squared. I squared becomes negative 1. So negative 36 times negative 1 is a positive 40. And so when we add together our real part, I jumped to the next part of the problem, is a positive 36. And when we add together 4 plus 36, we end up with 40. And when we add together our imaginary, they cancel out. So it leaves us the denominator of 40. Now we need to transfer it to the a plus bi format. So 14 over 40. The plus sign will just come down to the center. The I will come after the second fraction. And so we have 42 40ths is our second fraction. So now let's look at simplifying each fraction. 14 divided by 40 will reduce to 7 20ths. 42 divided by 40, if I divide both of those by 2, I get 21 20ths. And so now rewriting it, we have 7 20ths plus 21 20ths I. That's our complex number. Let's go on to number 11. 11, similar idea. So we're going to take our denominator and we're going to multiply by the conjugate of our denominator. And so for the numerator, all we're doing is distributing to both parts. So negative 45 and a positive 9i. And we're going to divide it by, and we have 5 plus I times 5 minus I. That gives us 25 and negative 5i. 5 times I is positive 5i. I times negative I is a negative I squared. And, oops, I'll put the C in the wrong spot there. Negative I squared. So we have a negative, and then the I squared becomes a negative 1. So negative 1 is a positive 1 as our answer. So when we add together our two real spots, we end up with 26. When we add together our imaginary, they cancel out. So we're dividing it by 26. Now let's split it apart into the a plus bi. So again, the sign in the center will go in the center. The I will go at the end. And the sign in the front will come in the front. And then we're going to have our two fractions. So our first fraction is 45 over 26. And again, that sign went here. Our second fraction is 9 over 26. And this sign went here. And the I went here. So when we look at 45/26, there is nothing that can divide into both pieces. And so that's as simple as it can get. So negative 45/26 and 9/26 is the same thing. There's nothing that can divide into both 9 and 26. And so this is your complex number you get when you divide those. Let's look at another one. And so here we take the same idea. We're going to take the complex number of the complex conjugate of our denominator, 7 minus I, and write it as 7 minus I over 7 minus I that we're multiplying it by. But now we have a complex number with both a real and imaginary in the numerator as well. And so when we do this, we're going to have to use a box for both of them. And so 7 times 4 is 28. 7 times a negative 2 is negative 14I. Negative I times positive 4 is a negative 4I. Negative I times negative 2I is a positive 2I squared. I squared becomes a negative 1. And that, when we multiply, gives us a negative 2. So 28 minus 2 is 26. And negative 4I plus a negative 14I, when those two combine, gives us a negative 18I. And so my numerator is 26 minus 18I. Now let's work on our denominator. And we end up with a 7 minus I times a 7 plus I. 7 times 7 is 49. 7 times negative I is negative 7I. 7 times positive I is a positive 7I. And negative I times a positive I is a negative I squared. So that's negative times a negative 1. And so that gives us a positive 1. So our 7 i's cancel out, giving us a 50. And so when I work this problem, I've got to take and look at simplifying it next, because I have to get it into that A plus BI format. So 26 over 50, and 26 was positive, so I don't have to write a sign here. The negative sign drops down, and then we have 18 over 50, I. Looking to cancel and reduce, we have 26 and 50, which are both divisible by 2, giving us a 13 and a 25. And 18 and 50 are also both divisible by 2, giving us a 25 and a 9. So when I rewrite my fraction in that format of A plus BI, I end up with 13 25ths minus 9 25ths I as my final answer. Let's do one more together, and then I'm going to have you do one on your own. So again, we look at this denominator, and we're going to find the complex conjugate of the denominator. So in this case, it's going to be 4 plus 5i. And then we're going to multiply our numerators together, the two fractions, and our denominators together. So 4 plus 5i and a negative 9 plus 2i. So that's going to give us a negative 36 and a negative 45i when we multiply our first column. Now let's do 4 times 2i, and that gives us 8i. 5 times 2i gives us a positive 10i squared. I squared becomes a negative 1, so that gives us a negative 10. So that gives us a negative 46 minus 37i. Now we have to multiply and get our denominator. And so we have 4 plus 5i times 4 minus 5i. 4 times 4 is 16. 4 times 5 is 20i. 4 times negative 5 is negative 20i. 5 times negative 5 is a negative 25i squared. I squared becomes a negative 1. So 25 times negative 1 is a positive 25. We're going to add together our real parts, and we end up with 41. When we add together our imaginary, they cancel out. So we're dividing that by 41. And so we have a negative 46 divided by 41 minus 37 divided by 41i. Because 41 is a prime number, we do not have anything that can simplify. And the last one you're going to work on your own. I want you to do 8i divided by negative 3 minus 4i.